Thanks, Michael. Yeah, thanks everyone. Welcome. I think we've got an exciting panel today to talk about the future of AI in insurance. I think quite a broad topic, so we'll probably cover quite a few different areas. Obviously, if you've got any questions as we go along, just raise your hand. I think a microphone will come around. I'd like to introduce our panel guests. So we've got Avinash from Good Driver, Sid from Hiscox, and Weijian from Marshmallow.
Yeah.
Avinash, do you want to give a quick intro?
Yeah, so I'm the founder for Good Driver Car Insurance. We are building an insurtech company. Monthly, pay how you drive, usage-based insurance, all in a super app. So yeah, pretty excited about doing that and happy to be here.
Thanks.
Cool.
Weijian?
Hi, my name's Weijian. So I'm a machine learning engineer at Marshmallow. So I'm sitting in between engineering and data science, sort of like trying to bridging the gap if there's any mismatches. And my previous experience, actually, I did PhD in applied mathematics, and I for a couple of years, I also working as a data scientist. So I try to sort of thinking from both the data science angle, also the engineering angle of the problem.
Hi, I'm Sid, and I'm the manager for advanced analytics at Hiscox. I lead a team of very smart data scientists and analysts around US, Europe, Asia, and we are delivering insights using machine learning, natural language processing to the business operations and helping out BAU as well as long-term projects.
Thank you. So to start off with, what technological advances do you see becoming the norm in the next 5 years?
You want to go?
So I think maybe I'll start.
Yeah, go for it.
So I think initially when data scientists started, as we heard a lot, we love Jupyter notebooks, but we also hate Jupyter notebooks. So the data scientist of the past few years has been working on a Jupyter notebook on his laptop, delivering insights as an exported CSV or a dashboard, etc. I think the technologies which are coming to fore and is now really essential for data scientists to build are MLOps. It comes from DevOps, where data scientists, instead of working in the silo, become an integrated part of the cloud infrastructure. So for example, at Hiscox, we are investing into Databricks and Azure, so that we can integrate the work that data scientists across the globe are doing, collaborate on various technologies. So adoption of cloud, adoption of the new ML ops, CI/CD, collaborating using Git repositories, etc. So these will become norm for data scientists rather than just working on their own laptop in a corner.
Yeah, I actually agree with your point. And actually, I just want to point out there is a lot of very quick innovations around like MLOps world. And the recent thing I noticed is actually quite interesting. Like in Google Cloud, they introducing called Auto ML. So in sort of in Amazon Web Services, they introducing something called SageMaker Autopilot. So those kind of technology basically allow someone who have no program experience to deploy machine learning models in production right away. So you can basically just loading the data in, and they have some standardized framework to enable that deployment like very quickly. And you basically the knowledge you need to gain is more about understanding of the data and understanding of the problem. So I was basically thinking the sort of like this whole direction is moving towards the cloud, and it tends to be standardized. So at the beginning, you will see a lot of different kinds of ML op tools, and I think over time it will becoming more standardized. That's how I think about it.
Yeah, I feel for AI you need data, right? And bigger organizations have them, smaller don't. The bigger organizations now are going through either getting rid of their legacy tech and getting onto newer platforms where data is in the right format. So before we think about the future, if you look at short to medium term, as they move on to newer platforms from legacy, their database or the data structure is getting, the data quality is getting right. And then the next step is to go on cloud. So now companies are moving from on-prem to get on cloud. So as they get rid of legacy, and then get onto the cloud, then this can be deployed at scale, and then AI will come to its own power at scale for these enterprises. Technology-wise, it will be speculation how the future would be, but I think before you run, you need to walk, and so getting rid of the legacy and getting on the cloud is important. But then also to think about from people point of view, it's all about top-down sponsorship also. So you need, I don't know, a chief data officer or digital transformation to not only think about digital, but also about analytics in a big way. Yep. And then on top of that, which is even more interesting, is when we talk to people, we find that customer centricity is even a bigger challenge, and there is no owner of the customer. So you might put analytics in silos in the organization without thinking about a connected journey for the customer to bring in the value. So when we talk about chief data officer and sponsorship from the top, you might think of a chief customer officer. And the more the silos, it's bad. It's perhaps not saying create more silos and more officers. It's all about how we can be agile and really cross-functional collaboration, keeping the customer at the center, because very quickly things can happen in silos. For example, you could see a lot of algorithms or pricing happening in the pricing world, but not much in the fraud world, or not much in the claims world. And in the end, the customer journey matters too, apart from the data. So when organizations become aware, sponsor these projects, only then AI can move at scale.
Thank you. Talked a little bit about some of the tech that allows democratization of like auto ML, model deployments, low-code environments. How do you see the role of actuaries, data scientists, and engineers evolving in future?
Okay. So shall I start? Yeah. So the role of the traditional insurance roles, actuaries, underwriters, claims underwriters, will evolve with the emergence of technologies and adoption of AI and other techniques. Now, I work in the claims side of our business, and with AI, I think claims is going to get, let's say, automated. So, for example, there's this new insurtechs that are able to settle claims within a few seconds. You take a photo, you send it, that's there. But what's going to happen is that the human role, the human claims adjuster role, will become more of an emotional role, so where you need a person to relate with the claims adjuster. So an algorithm calculates that, your house was damaged in a storm, and so with our algorithm, this is the amount that needs to be paid. But then showing compassion, relating with the person who's lost something or someone. So that's where humans will do more human-like work. So that's where AI will free them up so that they can do more human-like work. So that's what will happen. In terms of a lot of technology, sometimes there's a bit of an overhyped cycle. For example, a good example is the autopilot on Tesla cars. Even though the car can drive itself, there's a regulation that needs a human driver sitting in the driver's seat. And I see the same, where even though we might have algorithms and AI making some decisions on underwriting or the claims side or actuarial decisions, a human oversight will always be necessary. I think through regulation, through requirement by people, I think it will be necessary. I remember from Michael's talk yesterday when he said that he's able to automate the typical actuarial role, but the fact where the salesperson, where he goes and keeps a hand on your shoulder and tells you that this is what you really need, looks into the eye, and then after he's made the sale, pats on the shoulder and says you made the right decision. So these are the emotional, compassionate, and human traits that will continue to be part of most of the roles, and AI will only do the more menial or arithmetic work so that people can do people work.
Yeah, I kind of agree on your point. I think it kind of the thing will be the AI and the human will have some kind of a symbiosis relationship. So I think in my talk yesterday, I sort of pointed out very bold statement to basically saying, if you design the AI system very good, it should outperform pretty much every human being in decision making. I think like in general, humans are pretty bad at making decisions under uncertainty, and those kinds of choices should be left on AI. So I really believe the sort of, if you think about the underwriters or other roles, the essential job is really to make decisions. And I feel like the interplay between them and the AI will be sort of change a little bit. So they're basically providing the data, providing all kinds of angles for judgment, and it's the AI sort of combine all different judgment to make the final call. I think that would be what I would see the better choice of the future. So it's kind of like, I'm not saying the AI is taking the job away from the human, but the human is basically allow the AI to make a better decision. And the human's role is more like communicate with other humans, because you need some expert to interpret the result from the AI system. So the role of actual area science is mainly I have to communicate. So like a doctor talk to a patient, talk to a patient. I have to explain to another patient like why I'm making the specific decision. So it's not they are no longer the decision maker. They are more like a facilitator. That's really how I think about it.
Yeah, I couldn't agree more. I think the way I would put it is, I mean, repeat the same point really, is it's half art, half science. And AI, you are predicting on past data performance. So for example, you take the case of COVID. You have lots of accident frequency data and you are making models, and then COVID comes and then people stop driving. And then you have no clue what is going to happen next, and then human comes in, right? You debate, you put art in it, you do use logic. AI cannot, at least even in the medium to long term, replace that. Yeah. So the half art part of data science is always going to remain, and actually I would argue that's the unique selling point or competitive advantage for organizations, because the other AI part, the models, the way they work is getting more and more common, the same libraries, yeah. Etc. So for example, we are talking about at Good Driver creating a driving score by driving behavior. So yes, you get per second driving data from your telematics box or your phone sensors, Internet of Things data, connected cars data, and then you say, yes, we have a huge data, per second data, and then we will predict the driving score. AI can do that, and then it will tell you the most predictive variables. But then there is an art part. Somebody has to sit and say, should we look at lane changing behavior? Or should we look at traffic light driving behavior? And then you segment these specific use cases and then use AI to do things. So the half, as I said, the half art part is very interesting and a competitive advantages for organizations. And just on the role part, I think, and this might not be a common opinion, but I think we need both. Agile is a cliche now, but cross-functional teams, but cross-functional talents too. What really saddens me, and I'm probably coming from my startup point of view, but is that you need first a data engineer, then a data analyst, then a PA, then a data scientist, more or less doing the same thing, and all of them are smart people. So why can't maybe one person or two person do this job of the four people? But I see more and more siloed roles coming up in the industry. I would say that data engineer and data analyst could be the same person, more or less, which makes your teams, of course, you can have them in silos and there might be challenges, but either if you have silos, then make agile, scale agile, make them communicate, make them sit together, or else hire people who have both the skills, and maybe the industry might move towards that to remove the silos. But, yeah.
Thanks. And on the subject of, I guess, attracting talent, particularly tech talent with the right levels of skills, how does the insurance industry, perhaps not known for having the most cutting edge of technology compared to some of the other industries, how do they attract and retain top tech talent? can start with Avinash first.
Yeah, I can go there. So before Good Driver, I was part of Admiral for 6.5 years, and Admiral is based out of Wales, and you really get a lot of talent there in terms of operations and cheaper talent, if you like. But in terms of technologies, it's always a challenge, and the things that we have seen in acquiring talent that works is the graduate programs that we have. We collaborate with the university. We allow PhDs to come in, do a piece of work with us. There's a huge rotational program for graduates coming out of the university. And I think that helps a lot because you really find some really smart star people, and also solves the problem of training them. So you understand, right? Like you might know data science, but you might not know the domain, how insurance works, how pricing works. In fact, what we used to say was that you take at least 6 months first to understand how the book moves and how the variables move before you can jump in and model it, because you need to understand the domain, the business domain of insurance. So there is a huge learning curve, and resources can be costly. So what we have seen, at least within the realm of Admiral, was to get talent out of the university and collaborate with the university where possible. And that has given us some good results. From my startup point of view, now I'm like bootstrapping things up. But I was able to find talent back in India through my network. So outsourcing is always an option, and of course they're coming up in Europe and many parts of the world. And then there are many models. So you can have a whole software team dedicated to you, or you can hire freelancers, or if you are doing some test and learn, proof of concept kind of work. So outsourcing is always an option, and very interesting models. We worked with a company in Romania who could just stand up the whole tech team, so front end, back end, APIs, and then just ship to the. I mean, they just ship the product to you, working with you in an agile way, and then you just pay monthly. So though there are models of, but that's not a sustainable one. Yeah.
Cool. From my point of view, I feel there is in this industry there is a misunderstanding of what is a good talent in the AI space. So my feeling is like people, like there's a famous competition called Cargo competition. You can join it online. So people sort of think the data scientists are the guys who should like just build a model. And in fact, in my view, like building model is actually very easy. You can actually just download this somewhere. Like on GitHub, there's loads of open source project you can download. They actually perform very good. And I think a good AI talent will look like someone who can making changes at very rapid speed. So say I'm developing a model and it's already in production. A good AI talent would be able to tell if something's going wrong, how I can change things very quickly. Maybe I can introduce some like active feedback loop to sort of automatically adjust the problem. And those kind of things are very hard. And so like I think a lot of, if you see the kind of the job ad, they always focus on how many paper you publish, like what kinds of research background. I think that's actually not so important in industry. What's actually important in industry is once the problem is I have already built this thing, and it's something like the world is going uncertainty, the missing data is all coming out, how I can sort of very quickly adjust the problem and solving that issue. And I think there's a little bit like mismatch there. And like if we can really sort of try to identify the right talent, we may actually find the right talent. That's how I think about it.
Okay. Yeah, I think some very important points made there, and I would concur. I think the pandemic has actually opened a lot of doors for insurance industry. So you're not limited to your current geographic boundaries, but you can get talent from anywhere. One thing that I would say that for insurance companies, especially in the city of London, the 1 square mile next to, great way to attract talent would be to just let people wear jeans and t-shirt. I was just discussing with him that, oh, Marshmallow AI, they let you wear anything. That's amazing. So, so there's these tangible benefits in terms of salaries, holidays, bonus, and etc. And then there's intangible benefits where the size of the scale of complexity of the problems. Data scientists, they love complex problems, and insurance there's no scarcity of complex problems. Hiscox being a specialty insurer, there's some of the risks that we insure are really complex. How do you price these risks? How do you come up with the probability of the risk being realized? So statistics and AI and machine learning is about probability, and insurance is all about probability. So the complexity is there, the scale of the challenge is there to attract the right talent, I think, is there. Due to the pandemic, now the doors are opened. We need to explore opportunities where people can work remotely, giving them that freedom where they can build their projects or whatever remotely. And so that's really the key right now. And technology, ensuring that insurance being a highly regulated industry, just like many financial services industry, ensuring that you are able to give the data scientist a free hand in adopting new tools, adopting new technologies is especially critical. You know, your data scientists are going on Stack Overflows and all these, finding new ways to do stuff, and then only to realize that they are bounded by the IT firewall. Oh, I can't install this package because it's not understood. So ensuring that we are able to remove a bit of the red tape, give more autonomy. We are trying to make our data scientists more autonomous, giving them some exciting challenges to solve, and bringing ideas to the organizations. I think that is one way to attract and retain talent in the insurance industry.
Yeah, I mean, I can't agree more. I didn't touch on retention, right? Retaining employees, like getting employees is great, but what I'm saying is there's a huge demand for data scientists, and attrition is through the roof. People just get amazing salaries, and then they just move. And then given all the benefits, you can't just beat an amazing package. And this is just happening. It's happening in India a lot. And there's a lot of talent there, and I was talking to people, and they say, we hired someone at an unbelievable package we thought we'll never give, and we gave that, and then they left in 3 months. And this is common. This is not like just one person saying that. So yeah, as the demand for the real nice talent goes up, attrition becomes a challenge, and I don't have an answer, but you said it really correctly, like giving them a free hand. The culture matters. You can innovate. Here is your machine. Forget the firewall, download, do the best, excite us, surprise us. And I don't know, how do you measure performance and give incentives? Because it becomes difficult, right? But then there could be something related to innovation, and then people will start creating things. And maybe that keeps them, keeps the attrition low.
Yeah, good points. Yeah, and like another good example would be something like Macs versus Windows laptops. A lot of developers work on Macs. That's kind of what they expect. I think when they come into an insurtech environment or a startup, but actually a lot of incumbents, I think, find that most of their staff will have Windows laptops. So yeah, something to think about. And so speaking of incumbent insurers, I think a lot of incumbent insurers are obviously, like, digital transformation is top of a lot of companies' agendas at the moment. Where should they look to start to make advances in its AI and digital strategy?
Weijian?
Okay.
Weijian.
That's actually, you might have quite a hard question. So I feel like, in general, pretty much everything, so just back to my previous point, I think a lot of things related to human decision making should be done by AI. And if you're thinking about like how companies can sort of start using AI in some of their areas, I actually think they should start thinking about using some kind of, actually they can start with some simple rule case. It's not necessarily need to be very high AI system. It should be start with something very simple, trying to say like, I've already make a human-based decision, and if the AI system making a sort of like a little bit different decision, why that decision is different from what I can learn from the AI system. And I think if we're building some very simple rule system inside the company, and that becomes standardized, we may need some people, could be analysts or data scientists, to improve the system. And as the system getting better and better over time, it will sort of attracting more people to working on those kind of interesting problems. I think that's how I think about it. In short, I believe like we should start with something very simple. We shouldn't just tackle the kind of the huge problem like a human interaction. That will be very hard to tackle. We should start with something very simple and like decision making under uncertainty. That should be the first thing to go.
Sorry, can I understand the question once again? What about the
incumbent?
So
where should incumbent insurers look to start when they're looking to make advances in their AI and digital strategy?
Okay. Yeah, I think the areas where AI can be applied in the current incumbent insurers, I think at customer touch points, so claims, I think it's a very good area for applying AI to give a better experience to our customers, trying to make it as the claims process as smooth as possible, so that it's not caught up in the processes or the regulatory, not regulatory, but the chain of process can be more smoothened with AI. So that's one low-hanging fruit. Premium pricing, I think one example that we saw from Michael's presentation yesterday was that instead of filling out forms which don't maybe make sense, just a picture of the person was able to, you're able to price policies really well. So I think that is another area where insurance and AI can be easily applicable. And it's very important that insurers actually adopt AI and start adopting all these new technologies, because there's threats from technology providers who are now becoming insurers. So because if insurance is all about just covering the risk, what's stopping a technology provider from becoming an insurer? Okay, I'm selling you a phone, I might as well sell you a protection for that. So a lot of technology companies are actually offering insurance as well. So that's the threat from technology companies. Then there's Tesco underwriting. So companies which have not much presence in insurance industry are offering insurance services. So insurance becoming highly technical, highly automated, highly artificially intelligent also presents some threats. And so incumbents cannot rely on the old techniques and old processes, but identify opportunities where we can optimize, we can employ technology so that we move ahead and move fast with the changing times, because the industry is changing. There's new insurtechs which are cloud first, mobile first, AI first technology startups who are coming to the 100-year-old insurance companies, and that's where I think the gold is. Having said that, retail insurers who are offering retail plans, I think that's which is ripe for disruption, and that's where AI is currently applicable. However, if you go to Lloyd's market, where some of the most complex and biggest risks are written, it's still a very manual human touch process. You will still see people going around with suitcases. So I think those are the areas where AI has not gotten to as much as in the retail. So I think those areas, it might take some time, but yes, retail is the first place where AI and technology is going to make a lot of headways.
Yeah, I think I read a couple of McKinsey papers and framework around this. So I'll talk about probably a framework of which incumbents can consider while thinking about digital transformation and AI. So the first thing to note is that the customer is the primary axis of change. Everything you are doing is to make that customer journey better, faster, cheaper, or better, manage risks better, right? And then so once you understand that customer is the primary axis of change, then you start mapping all the processes, and as you said, customer touch points.
Yeah.
And without boiling the ocean, without saying, okay, a big organization might have hundreds, if not thousands of processes. You look at the top 20, the most heaviest process, so maybe sales, ethanol, fraud. So map your top 20 processes, which take the most of your customer touch points, most of your operations, time, etc. And maybe that's where you have the most data because customer touch points are more. And then simply go, okay, what in this process can be digitized or can be AI driven? And you might surprise yourself saying, well, we do a follow-up campaign, but we follow up with 100 people, but AI can tell us to follow up only with these 20 people where the propensity of buying is more. Things like that. So you have to sit down, map those processes, but then there are many more advantages. While you are doing this, while you have these processes written down, mapped, and you are transforming parts of that process, this will be digitized, this will be an AI decision, no more a human decision. At the same time, in the process of avoiding wastage, you are becoming lean. And then so you can do all this lean process management also while at it. And in my experience, if you go and ask bigger departments about process flows and maps, it's not there. Trainers might have that in their mind, and then they train employees, and it goes in the old ways. So I think that's a really nice framework to think about mapping and then finding out which can be digitized. And then, of course, if you think about columns, you could say customer value, effort, risk, regulatory constraint. Rank them up, choose your top 5, start there.
Yeah, I completely agree on that point. So I sort of just following up on your point, I think we should have a good metrics first. So it's before doing anything AI, we have to collect good data and building the right metrics and using that to define what kinds of the problem we need to tackle first.
Thank you. So I'd pause there and see if there are any questions from the audience.
Hi. Thanks for the great discussion. I have one question regarding the openness to technology, and as a data scientist, I love it because if there's a package I want to try out, want to download it and just run with it. But how do you balance this with data security? Because I mean, with there's obviously some highly sensitive data involved usually, and so you can't be as open as you probably would want to be. So where do you draw the line? Do you have like separated testing fields or something like that? So how do you manage this?
So I could add that. So I think there's, in every industry, there's areas that are regulated or subject to regulation and highly controlled. And then there's areas where the data is not sensitive, that may be not subject to regulation. So I think you start in these areas where might not be highly regulated. For example, something that could be a marketing area where you have promotions and automating campaigns, for example. That is a great area where you can just apply without worrying about the sensitivity of the data or customer data, for example. But then there's areas where you are dealing with sensitive data. So that's where you cannot give a free hand and it has to be highly regulated. So identifying these areas where there's not a lot of red tape and you can easily apply new and emerging technologies.
Yeah, in my experience, usually in bigger organizations, you will have either some kind of data governance transformation going on in some shape or form, which would be like, hey, these are the procedures and policies. This is how you should do the data dictionary. This is the data quality, and follow these guidelines. And then, of course, you will have a compliance team or the data protection team looking at these projects and signing them off. And I think where it can help the data scientist team or the AI team is to engage with these different organizations. And again, I go back to cross-functional and agile, which is engage with these departments before And yes, they seem like roadblocks, but you would be surprised very early on. They can tell you these are the barriers you will face in the project. So yeah, look out for the data governance teams, policies, procedures. And this is the boring stuff, and this is what I yesterday in my talk alluded to, that a predictive model is just the tip of the iceberg. Also, data management. So, for example, you have to delete the policy data after 6 years. So there are rules around data management. What you can use is one thing, but then you have to delete data. That's another thing. So you have to then talk to IT, and then the data management, which is not the sexy part as data science, it comes into play, and you can't ignore. And so, well planned, half done. So plan better, engage earlier, which will then either just kill off your project or help you pivot very early on, rather than investing 2 months doing this model and then finding out you can't deploy it.
I'll give an example, not specifically from insurance, but from pharmaceutical. Again, a very regulated industry where you have comments from patients, and obviously it's patient identifiable information, highly sensitive. But there is a lot of value in that data, and pharmaceutical industries cannot use that because there's a regulation from the FDA that if you become aware of side effect, also called as adverse event, then you need to report. So they are very worried about all that. So again, AI was able to help use this data by anonymizing that information. So if you remove patient identifiable information, and that can be done by algorithms such as entity recognition. So again, if you are able to sanitize the data by removing any sensitive information, then you're able to use that.
I can give you a more technical answer. So at Marshmallow, we're actually using Snowflake as our data lake. So we actually be able to manage it so that each team have different access rights. So that means for, like, say if you think about the data will be like a big table, right? So certain column can only be accessed by certain team. So you have that kind of level of control. Another thing we did is we move pretty much all the training data on the cloud. So it's kind of it's an interaction between S3 and the SageMaker. So there's no data downloaded on their laptop. So that's remove some kinds of issues that you have user data sitting on a laptop. So we don't have that anymore. So I think it's kind of like probably engage with the data engineer and also like the machinery engineer team. So the fact building that kind of infrastructure to allow you to access the data at the right level.
Yeah, and probably one thing to add to that is, from my experience, I think there are certain types of data sets and protected attributes that you might not want to use in your predictions because you don't want to unfairly penalize based on gender or maybe based on ethnicity, so you might want to remove those from your features. I think what can happen is that there are causal relationships in the data that even by removing those attributes, you're not necessarily removing that data from your data set. And the relationships, when we're looking at sort of like causal or Bayesian relationships can actually be very complex to model if someone doesn't have a deep statistical background. So in those cases where we are working with that kind of data set, particularly in healthcare, it's quite important to try and bring in the experts to try and identify where you could have those correlations in your data so that you're not inadvertently using data that you're not intending to use. We've got time, I think, for another question. Yeah, I think this gentleman in the front was first.
Oh, no, okay. So something completely different. I'm quite excited about reinforcement learning. I think that's a very fascinating field. And well, I guess I'm a bit disappointed that I haven't seen that much reinforcement learning in our industry in the past years. So, well, my question is, do you use it? Have you any use cases that you tried out, and what's your future expectations for reinforcement learning methods?
I can start, yeah. So it's a very good question. So reinforcement learning is quite applicable in many areas where you have not as much sample data. And yeah, a bit disappointed that I haven't seen examples specifically in the insurance industry. I've been only a 1 year in the insurance industry, but at least I've not seen it. But yes, if we are in the areas where we can apply reinforcement, where you don't have enough sample, and then you want to apply and learn with times, I think that is where it can be applied. And I would be quite keen to see in areas where I think new risks and new developments, I think that could be a place where we can try to apply reinforcement learning. Do you have any?
Oh, cool. My short answer is no. We currently don't use reinforcement learning. And the reason, I'll give you the reason. So from my understanding, I'm not expert in this. Like my understanding is to do that very well, you have to have a clear defined reward. So to make the system, have a correct feedback loop to get it all working together. But it's kind of like quite fuzzy to define it clearly in sort of insurance world, in my opinion. But I feel like there could be some kind of combination of feedback-based loop inside of a traditional machine learning system. So you're thinking about certain features or the weight of the feature, the importance of certain features can be you can define that using called active feedback loop. So it's sort of like based on user data interaction for the previous day or so to just adjust that in real time. That could be happening. I mean, it's not perfect reinforcement learning, but you get some features of reinforcement learning inside the traditional like training, called supervised machine learning system. But I will be very interesting to see how that evolve. But my understanding is been working very well in gaming, sort of like AlphaGo stuff. But I just don't see that in real life. That's my feeling.
There is a cousin of reinforcement learning, which is also called as active learning. It's not like a proper machine learning technique, but it's like where you are trying to give a feedback, the loop that Weijian mentioned. So we're trying to implement that where we do not have enough sample data, but we are trying to build something, a base model, and then trying to improve that with constant user feedback. So that's the sort of cousin of reinforcement, if I may say.
Yeah, I mean, I don't know much about it, but you have given me something to research about.
I would probably just say quickly, I know we're at time now. One thing I think that Key has really considered on the reinforcement learning side would be a good example to maybe even just try, would be trying to model something in the Lloyd's market. The Lloyd's market has a number of brokers. For every risk, there are a number of syndicates. And syndicates can effectively be agents. So you can either model that as a single agent problem where I'm the syndicate, I take an action depending on the line size or what risk I want to take up, and I get a feedback from the market. And then over time, if you have different agents taking different decisions, what happens naturally in the market is a cycle. So you have a cycle where market hardens, prices are higher, profitability is up, more entrants. That means that there's more competition, prices lower, and then we become into a soft market. Now, multi-agent modeling, some kind of reinforcement learning, I think would be quite an interesting application to see how modeling that market cycle could happen, and can we predict future market cycles, and how long do they last? I think we're at time now, so yeah, thank you for everyone for their questions, and yeah, thanks to our panel as well for all of their answers.
Thanks for the coordination.
Thank you for coming.